welcome to you e-learning program by Modern English School, New Area, Nevada. Myself, Sujay Kumar, mathematics teacher, Modern English School, New Area, Nevada. A student, today I discuss exercise 10, some important questions of trigonometry. So student, please see exercise 10. I discuss again some basic concept of this exercise and some important questions. Exercise 10, our question related is right angle triangle. A right angle triangle is a triangle in which one and only one angle is right angle. So I draw a figure ABC, right angle AB, then ABC is right angle triangle. If it is right angle triangle, then it is clear, it is perpendicular, it is base and it is hypotenuse. It only depends this angle. If angle is C, then perpendicular is P. If your figure is like as and it take angle A is here, B right angle A is here, then perpendicular is this and base is this. Hypotenuse is always constant. Hypotenuse is opposite of the right angle is always hypotenuse. So only change is perpendicular and base. When angle take A, then perpendicular P. When angle take C, then perpendicular P is AB. When angle take A, then perpendicular is BC. There are three terms: perpendicular, base and height. So their relation between perpendicular and hypotenuse, it is called sine. Suppose here is C, so we write sine C. For base by hypotenuse, it is called cos C. And perpendicular by base, it is called tan. So it is tan C. If C is related to theta, beta, alpha, gamma, n, then you can say it is sin theta, that is P by B. It is cos theta, that is B by H. It is tan theta, that is P by B. Reciprocal of sine is called cosec theta. Just reciprocal. That means it is H by P. Cos theta reciprocal is sec theta. So it is H by B, and reciprocal of tan is cot theta, so we can say it is B by P. Similarly, you can find the other value like as hypotenuse according to the Pythagoras. You use this formula P square plus B square. B you can find by the formula H square minus P square, and P and the formula you can use H square minus B square. So in this figure there are three ratios. If 2 is given, then you can find third with the help of this Pythagoras formula. Some angle related as, suppose this is written as, then it is called theta. This is written as, it is called beta. This is called alpha. This is called phi, and this is called psi. This angle has no any personal value. It is only the naming angle. So some angle theta, then it is sin theta. If it is beta, then it is sin beta. No any change. Sin beta also P by H. Cos beta also B by H. So student, now discuss some questions of this. See here question number 2. Solve example. That is, if cos A is equal to 9 by 41, find the other trigonometric ratio. There are 6 trigonometric ratios. One is given. That means we will find other 5. So first you in every question write solution, and first you work to draw a right angle triangle. And if A is given, then always write A is here. When you write A is here, then BC is the perpendicular, AB is the base, and AC is the hypotenuse. And it is given cos A is equal to 9 by 41. So cos A is equal to B by H. Now suppose B is equal to 9x and H is equal to 41x. So B is 9x and H is 41x. We take x because it is given in the ratio form, so we take here x. Now you have BC. BC is equal to AC square minus AB square. According to Pythagoras theorem, perpendicular is equal to hypotenuse square minus base square. So AC square is equal to 41x whole square minus 9x whole square. You get here 1681 x square minus 81x square. It is equal to 1600 x square, and that is 40x. Root of 600 is 40, so it is 40x. Now cos given, so you find sine. So sine A is equal to P by X. So P is 40x and X is 41x. X is cancelled, so it is 40 by 41. Similarly, cos is given. Third tan A is equal to P by B. P is 40x, B is 9x. So tan is 40 by 9. Similarly, cosec is the reciprocal of the sine, so it is h by p. Then you can write 41 by 40. Sec is the reciprocal of cos. It is formula h by b, and sec is given h by b. So reciprocal of this you can write 41 by 9. And last time cot, and cot is the reciprocal of tan. It is b by p. So p by b is 40 by 9, then it is 9 by 40. So that's how it is a 5 solutions of this equation. Next question is question number 8, and that is, if 5 cos theta is equal to 3, then find the value of 5 sin theta minus 3 cos theta by 4 sin theta plus 3 cos theta. Here is value when 5 cos theta is equal to 3. So first we find the value of cos theta, that is 3 by 5. Now we want to change the odd term in the form of cot. So here is sine and cos, here is sine and cos. So first we divide numerator and denominator by sine. What you get? You divide this term by sine, this term by sine, this term by sine, and this term by sine. So we divide here 5 sine by sine minus 3 cos by cos. So this sine and sine cancel, and 4 sine by sine plus 3 cos by sine. So this sine sine cancel. So here you get 5 minus 3, and cos by sine one is identity, that is cot. So 5 minus 3, it is cot theta, and 4 plus 3 cot theta. And you have the value of cot theta is given. So only substitute the value of cot theta, then you find the solution, only do some calculation here. So we write the value of cot theta 3 by 5 here. So we write 5 minus 3 into 3 by 5, and 4 plus 3 into 3 by 5. What we get here? Here get 5 minus 9 by 5 and 4 plus 9 by 5. We take here LCM 5, that is 25 minus 9 by 5, and here LCM 5, then 20 plus 9. And lastly, you write here, that is here 25 minus 9, that is 16 by 5, and it is 29 by 5. And then it is 16 by 5, and this line is divided. So interchange it, you write 5 by 29, this 5 cancel, so result is 16 by 29. This is the solution, so you can solve by easy way. Only change this term into cot and only substitute the value of cot, then you can find. Now see, questions number 12 of the examples. Question is, in triangle ABC, B is 90 degree, AB is 5 cm, and AC plus BC is 25 cm. Then find the value sec A minus tan A. Dear student, take care here. That is sec A. Here is A. So when you draw a right angle triangle, then you always write A is here. It is help to you. When you write A is here, then it is clear perpendicular is BC, and base is AB, and hypotenuse is AC. So your question is related to A. So A is always right here. If your question is related to B, then I write here B or C. So here A, so I write here. And draw a right angle triangle. That is angle B is 90, it is given that. So I write here B is 90, so C is there. And AC plus BC is equal to 25, given in your questions. We suppose AC will be X. Therefore, what is BC? So you can find BC. BC 25 minus X. Now it is a right angle triangle. So according to Pythagoras rule, AC is the hypotenuse. So AC square is equal to AB square plus BC square. Now put your value. AC is X. I suppose here plus AB is 5, given that in your question, and BC 25 minus x from here. And we solved it, and after calculation, you see here, it is x square, it is 25, it is a minus b whole square. So a square plus b square minus 2ab to a 25 bx. Here is x square, here is plus x square, so we cancel it. Here is only 0 remain. Here is 25, square of this is 6 to 5, and it is 50x. Now this is minus 50x, go this side, then it is 50x. And here is 625 plus 25, that is 650. After that, you find the value of x. 650 by 50, that is 13. So x is 13, and x is AC, so it is 13. The part with BC, BC 25 minus x, then 25 minus 13, that is 12. Now in this triangle, you have all three sides given. One is 13, other is 12, and third is 5. Then you can find the value of this. This is sec a minus 10. What is sec a minus 10? Sec a is h by b. What is h? 13. What is b? 5. Minus 10. 10 is p by b. What is p? 12. What is b? 5. 12 by 5. We take LCM, that is 5. And it is 13 minus 12, that is 1. And it is 1 by 5. So solution of sec a minus 10 is 1 by 5. It is your answer. Question number 14. Solve examples. Question is that 7 sin square theta plus 3 cos square theta is equal to 4. Then show that sin theta is equal to 1 by root 3. In this question, we use the identity. Like I first write your question, 7 sin square theta plus 3 cos square theta is equal to 4. Now 7 and this sin square change into 1 minus cos square. It is the first identity, and plus 3 cos square theta is equal to 4. Multiply 7 cos square theta, 7 minus 7 cos square theta plus 3 cos square theta. Then you get 7 minus 4 cos square theta, because it is minus 7, it is plus 3, then it is minus 4 cos square theta. Then here minus 4 cos square theta, here is 4, 7 goes this side, that is minus 3. This minus 3 minus 4 cancel minus, then here is cos square theta, 3 by 4. Here is 3, 4 go there, get 3 by 4. Then cos theta is equal to under root 3 by 4. Then value of this is root 3 by 2. Now we draw a triangle, right angle at B. And here is ABC. So we suppose this angle is theta. If this angle is theta, then perpendicular is AB, base is BC, and hypotenuse is AC. Here is cos theta, that is B by H. So B is root 3 and H is 2. Then you can find perpendicular. Perpendicular is h square minus b square. That is 2 square minus 3 square. 2 square 4 minus root 3, that is 3. 4 minus 3 1, that is 1. Then what is tan theta? Tan theta is equal to p by b. Then p is 1, b is root 3, that is 1 by root 3. 19. Exercise 10. 19 is if sin theta is equal to 3 by 4, then prove that cosec square theta minus cot square theta by sec square theta minus 1 is equal to root 7 by 3. First, what is given? Sin theta is equal to 3 by 4. I write here 3 by 4. And sin theta is equal to p by h. So first we draw a figure of right angle triangle. ABC. B is right angle. Then it is clear that AC is the hypotenuse. We write theta is here. Then you write theta is here. Then perpendicular is AB. Just opposite of theta is perpendicular. So perpendicular is AB. So remaining BC is the base. Now it is p by x. So p is 3x and hypotenuse is 4x. Because it is given in the ratio form. So you take ratio will be x. Then perpendicular is 3x. Hypotenuse is 4x. Then what is base? But according to Pythagoras theorem, base is h square minus p square. So I put their value 4x whole square minus 3x square. 16x square minus 9x square. That is root 7x square. That is root 7x. I write their value root 7x. Now your question is cosec square theta minus cot square theta by sec square theta minus 1. Cosec h by p. H by p means 4x by 3x. We write 4 by 3. Cot formula is b by p. B by p. B is root 7 and p is 3. So root 7 by 3. Sec. Sec is the opposite of cos. H by b. H by b. So 4 by root 7 minus 1. Then it is 16 by 9. It is root 7, so it is only 7. It is 3, so it is 9. Similarly 4, then it is 16. You root 7, so it is only 7. Here it is minus 1. Then you take LCM 9, 16 minus 7, 16 minus 7 by 7. What you get here? Here is 16 minus 7, that is root 16 minus 7, that is root 9 by 9, and it is 9 by 7. So you write under root 9 by 9, and this is into, because this line is a divide, then change the reciprocal, then it is 7 by 9. So we write 9 cancel. So it is root 7 because there is no any root, and it is 9, so it is the root of 3. So formula is root 7 by 3, it is the your solution. Exercise 10, question number 24. Exercise 10, question number 24. If x is equal to cosec A plus cosec, y is equal to cosec A minus cosec, then prove that 2 by x plus y whole square plus x minus y by 2 whole square is equal to 1. Dear student, first write solution, and your work is x plus y. So I write here x plus y and put their value. X plus y is cosec A plus cosec, plus y is equal to cosec A minus cosec. So minus cos and plus cos cancel, then x plus y is equal to 2 cosec A. Cosec A plus cosec A, 2 cosec. Similarly, x minus y. Then value of x is cosec A plus cosec, but here is minus, so sign will be changed of the y. So it cosec A, so I write minus cosec A, minus cosec, so I write plus cosec, because here is minus y. So cosec A minus and cosec A plus will be cancelled. So here is cosec plus cosec, you write 2 cosec. Now write LHS of this question. LHS is 2 by x plus y whole square plus x minus y by 2 whole square. 2, what is the value of x plus y? I write here 2 cosec A. So I write here 2 cosec A. And x minus y, what is the value? 2 cos A. So I write here 2 cosec. 2 cancel. Here 2 cancel. So 1 by cosec, sine, and cos is cos. So 1 by cosec square, that means sine square and plus cos square. And it is first identity, it is equal to 1. So we can say value of this is 1. That is now question number 29, exercise 10. It is the second last question of this exercise. This is 29. This question solve an example, very large method, but you can solve by these types of methods. So try to solve by this method. You save your time in the examination periods. How you can solve? First read questions. If angle A and angle B are acute such that sin A is equal to sin B, prove that angle A is equal to angle B. Question is that A and B are acute angle. Then prove sin A is equal to sin B given, then it is clear that angle A and angle B are equal. So first we suppose solution, let ABC is right angle triangle, right angle at C. What benefit of this? When suppose right angle at C, then it is clear angle A plus B is 90, because sum of 3 angle is 180. Angle C is 90, then it is clear A plus B is also 90. If the sum of 2 angles is 90, then it is clear both are acute angle. And your question is angle A and B are acute angle, both are acute. So right angle C is right angle, then it is clear angle A and angle B are acute angle. And now solve this question in only one figure, not like your example 2 figure. In only one figure, angle B is acute and angle A is also acute. And you have given that the sin A is equal to sin B, sin is equal to P by H. So for A, angle A, P is BC. For angle A, P is BC. So I write P is BC. Hypotenuse is AB, clear, because opposite of right angle is hypotenuse. Sin B is here, then opposite of this angle is perpendicular, that is AC. So I write here AC. Hypotenuse is constant, that is AB always. So I write AB. This AB and AB cancel. So what remains? BC is equal to AC. I write here BC is equal to AC. If BC is equal to AC, then by the base angle sides are equal, then in class 9 we read that if sides are equal, then their base angle are also equal. So angle A is equal to angle B, these are the base angle. So it is proved. The question is A is equal to B. Student, now last question of this exercise, exercise 10, question number 30. This question is like a 29. Here is angle A and B are acute angle such that tan is equal to tan. 29 sin is equal to sin B. But in this question tan is equal to tan B. Then prove that angle A is equal to angle. I write, draw a figure. Angle C is 90. Right angle triangle. ABC is right angle triangle. Right angle at C. So C is 90. Then it is clear A plus B is 90. Then A and B are acute. So A and B are acute angle. And now your question is tan A is equal to tan B. Tan A is equal to tan B. Tan A is equal to P by B. So this AP is BC and B is AC. I write AC. Similarly, tan B is here. So this B perpendicular is AC. I write here AC. And base is BC. So I write BC. There is no any cancel. But you try to cross multiplication. So AC square is equal to BC square. AC into AC, AC square, BC into BC, BC square. And remove the square, then BC is equal to AC. So what you get, if the sides are equal, then their base angle are also equal. So angle A is equal to angle B. Thank you.